Hello once again guys, you're watching High Voltage Mayhem, and today I want to bring you a video about an oscilloscope unit. So this thing I brought back the other day, this is a huge Bell Laboratories oscilloscope unit. It's got a frequency meter, it's got an oscilloscope, it's got a microwave meter, it's got all kinds of stuff. It's got a radio transmitter and receiver, RF oscillator, and a whole bunch of other switching equipment on the inside. So this is a really neat unit. A lot of this technology dates back to the early 1940s. However, this unit is comprised of mainly equipment from the 60s. So even though this is a little bit later in the time frame of equipment that I'm familiar with, still, we got some old 60s stuff to play with. So I would like to keep the focus of this video today on this frequency meter. This is a Western Electric frequency analyzer, and it allows you to see an input frequency on these digital displays. So if you'll notice, there's a whole array of NIXIE tubes up here, and that'll allow us to see our frequency. So quickly I'll show you how this machine works, and eventually I'll get to making a video on all the rest of it. But in the meantime, let's focus on this frequency meter and see if we can't get it to work. Okay, so with all new equipment it should come with a manual. So here I have the manual for this frequency counter, and as you can see there are two tables on this page. Now what these two tables for allow us to test this unit with its built-in test calibration setting. So if you'll notice on the machine itself, we have a function switch, and this allows us to change what functionality the machine is set for. So if you'll notice that it has frequency, plug-in, and test, we're going to use the test setting. Now this machine contains a built-in crystal oscillator that will send to the analyzer a signal. Now if that signal is the same throughout the gate time, that means this machine is working properly, or as specified by the manual, these are the values that we should receive on the display when the machine is functioning. So the first thing we do is turn the power on to this unit, and you'll notice we have a bad fuse. I've yet to fix that over there. So we'll turn the machine on by using this switch. We'll press the reset button, and now we'll watch the gate. Now what I mean by watch the gate, this is the gate time, or the amount of times it refreshes itself. So, or how quickly it refreshes itself, however, it gets a new reading on the frequency. So if we look at our chart here, you'll notice that that is displaying correctly. Now if we move this switch over, we should get a different reading on our manual. As you'll see, the reading has changed, and you get the idea. So if I move this switch over, we should get the same reading if this machine is calibrated. Now keep in mind, this is over 60 years old, probably approaching 70. So for this to be even operational is really a big deal. Nevertheless, to be perfectly tuned and everything, now you can start to see it calculating. Now if we move it up one, you'll actually see it has to add up to the right frequency. And here's the last one. I'm going to change that gate time. There we go. Now, if I adjust the sample rate at which the machine runs, you'll notice that it will count up and then stop and count up and stop. So if I adjust this rate just a little bit, you'll see it slows down and holds for a while. And then if I turn it the other way, it quickly adds up and counts. So this adjusts the rate at which it refreshes. Now if I put it on hold, it'll take the frequency that we've tested and hold it, and it won't increase any further. Now if I set the unit here to the highest frequency possible, you'll notice that it will count up, and then it should hold that frequency if operating correctly. And there we have it. So if we take a look at our book, you'll notice that all the readings are correct. After 65 years of sitting around, it still works. So now what we need to do is go into the back and hook an input into the back so we can measure our own frequency through using a function generator. Now just a word of warning, before you go and taking the back off of a unit like this, always make sure that the power is unplugged and all power supply and control switches are off before you enter a cabinet like this, because you can get electrocuted very easily, because there is plenty of thousands of volts in here just waiting to jump out and kill you. So if we take a look at the back of the unit, as you'll see, that's the oscilloscope, and here's our frequency meter, and what we want to do, or frequency counter rather, we'll want to look for the back where it says input. Right here, as specified in the manual, is the input, and it's just a coax cable, and we can hook in any frequency we want up to 10 volts RMS. So we're going to take just a coax plug, and we're going to go through the back of the cabinet like this on top of this aluminum rail, and I'm going to sneak and attach that little cable on there like so. Now should the machine need calibrating, there is calibration screw here and fine adjust there, so if you do need to adjust it and make any changes, you can do so. We also have a storage function, but that's kind of like an internal memory for your frequency, and I'll get into that later. But so we're going to hook that input into there, and then we're going to hook an audio source with a given frequency through my phone into this input on the back, and you'll notice the machine should light up. Okay, now before I turn this on and hook an input into there, I'm going to show you what I'm going to use. On my phone, I have a function generator that will generate a sine wave, square wave, triangle wave, or whatever through this input here and into the machine. So if you'll notice, I've got a couple things going on here. You'll notice that there's gate time. That's an indicator for when the machine is going to refresh itself. There's also an oven. You may be wondering what the oven light's for. The oven light is for when the crystal itself needs to heat up. So there's a crystal oscillator, like I mentioned before, inside this unit. And when that crystal is below its operating temperature, that oven will kick on and heat the crystal to the desired operating temperature. Now, I was going to make this video earlier today. However, the temperature inside the shop was exceeding the temperature this machine is rated for. Because here, where I live, it is very hot. So let's get this machine turned on and set to frequency. And I'm going to input on my phone a random frequency of 20 Hertz. Hopefully it will detect it. So I'm going to go 20 Hertz and then play. And there we go. We'll set the refresh rate where it's not so fast, so you can hopefully see that. 20 Hertz. And of course we make sure the gate time is set to Hertz. So this is like a multiplier switch, kind of. And there we go, 20 Hertz. Now, I'm going to input a different frequency of, say, 35 Hertz. And so hit enter on here, and it should register 35 Hertz on there. And it's registering correctly, and the decimal place is automatic. So if I take this switch, because we want it to add a little bit faster, we'll move that over. I'm going to input a frequency of, say, 300 Hertz, and you'll notice we can hear that sound through the speaker. 300 Hertz. Now let's pick a different frequency, just any random frequency. We can do 250. So you type in 250 on here, and you should get the same number on there. Now if we want it to hold, what I will do is unplug this speaker so we can go to a higher frequency. And I'm going to choose, well, let's just type in some random numbers. How about 1, 2, 3, 4, 5. And there you go. So you can just select any frequency on here you want. We're using a sine wave, of course, with decent amplitude because this takes a little bit of power. And if I put it on hold, it'll hold that frequency for us and we can analyze it. And of course, it'll take that same frequency anywhere else and calculate automatically. So 12.4 kilohertz, and then we can do 12.35 kilohertz, or we can just measure the actual frequency that I inputted, or we can switch the gate time switch so where it'll add up and move the decimal over automatically. So this machine does calculate and round and do things like that. So that's basically how you use it. There's really not much else to it. So, like I said, you can hook in a square wave, a sine wave, a modified sine wave, ramp wave, all different kinds of waves, and it'll still read just as accurate. And so if I just pick any one of these, I can touch 500 right there, and then adjust the refresh rate on here, and it should switch to 500. So you see, the signal is coming out of here and going straight into the back of the unit, where it's then registering with the NIXIE tubes. So as you'll see, this unit is fully operational. And I hope I've explained it to the best of my ability for you to understand how this thing works. Now I'm going to make another video about the rest of the equipment later on, but just for these purposes, you've seen how this frequency meter works, made by Western Electric, and you'll notice somebody scribbled some math on here. It wasn't me. But anyways, that's it. That's all I've got to show you about this machine. There's really nothing else to it unless you have a plug-in, which you can add on the back, and you can increase the frequency range of this unit. Now, just one word of warning. When you go messing about with equipment like this, always make sure to inspect everything on the inside first. Because like I said, this one was full of screws when I found it and taken apart and scattered. So I had to put it all back together and get it to work. So anyhow, that's basically all there is to this unit. So you just take your input, hook it in there through your phone. Very simple. Well, thank you for watching this video. This is High Voltage Mayhem, and I hope I explained this unit where it's easy to understand, because it's a very simple unit once you get to know and once you're familiar with it. So like I said, this thing's getting way over 60 years old and it's still working just fine today. Perfectly calibrated with no work needed. So, as you'll notice, the NIXIE tubes are displaying nicely, and this will last you a lifetime. So if you do run across one of these instruments, I highly recommend you pick one up, because they're just as good as any modern equipment you'll find today, as we've seen from the test today. So once again, thank you for watching this video. This is High Voltage Mayhem, and I'll see you later.